we are AIX Technologies, and we've been focusing on bridging the gap between real-time asset optimization and remote risk intelligence using immersive digital twinning, which has applications for people who want to, companies who want to use it for their staff remote learning development, for health and safety, and also if they're really advanced and they're using robots on the sites, then you can use our technology to do that. And our technology comes with its hardware, which is our AIoTs, which can be deployed on the site and can be managed using our digital twins. And the industries that we can apply our technologies are all the way from construction to oil and gas and ports and logistics. Anything that has an infrastructure can be managed with our technology. And needless to say, there's two major problems in asset management: managing them, and at the same time managing your resources on site. And if you're an insurance company, then you have to deal with the loss ratios that's happening on the premises and your assets. So this is where we are bridging the two industries. And now I pass to my colleague Mohammed Reza to showcase what we've been up to. Thank you.
Good morning. Let me share my screen. And I'm interested to share last two projects that we've done based on IoT and machine learning and digital twin. Can you see my screen right now?
Yes, we can see your screen.
Yeah. In last project, we did a project with Nottingham Trent University corporations in doing a church project, or the Nottingham Cathedral project, that you can see monitoring this heritage building. We're monitoring temperature and humidity, air quality, and we're using AI to analyzing this data. And we present this data in two forms. You can see this is the data, history of data. Here we can see every detail of data, history of data, performance. And on the other side, we have a digital twin 3D models that you can see here, a sample, how we can use virtual robot to walk to the building, to check the sensor. For architect that are interested to see the layout of the buildings. And this is the model we generated for a researcher to find out how they can improve this heritage building, because the challenge we have here in this building is a high humidity level. The researchers trying to find out, based on the analysis data and the modelings, everything, to find out how they can improve these buildings. You can see any detail, because this is laser scan, every detail is there. Measuring, simulation, whatever you want. You can see all the sensor installed in the church is there. And every corner they want to monitor, exam they can do, or see, you can use simulation like a dehumidifier, how it can impact the reading of temperature and humidity in this building is possible. This is one project. And the other project that I'm interested to share here is, let me share this one. The real one, let me show you here. Also, we're using digital twin IoT in level 4, digital twin level 4 for energy optimization in the building. You can see this is the one project, is a 3-bed house that we're monitoring temperature and humidity, air quality as well. You can see history of data here. And also we are able to, like the other one, we are able to walk to the building and see exactly what's going on there. We can walk to any corner of the building. We can see the detail of informations. And this is a good technology, for many users based on the requirements. If it's data analyzer or is the architect or whatever, this kind of technology can provide information for them. Or even we can put it in the play mode. Let me show you as a virtual robot to walk to the building, to investigate the building layout. You can see I can walk anywhere it's exactly the same layout as of the building we are monitoring. And interestingly, this is this full automated system that we use this AI to monitor and control the thermostat. And in last 3 months, we are able to manage 30% saving in this building only by monitoring the advanced, sensor and thermostat that it can control by AI agent that is optimizing temperature in each level and each rooms, because we have occupancy level, we have temperature and humidity. Yeah, it was a good achievement. We achieved 30% saving in this building based on the information without any alteration to the buildings. Yeah, thank you.
Thank you, Mohammed Reza. And this was just a simple scenario if you're into construction, homes, all the way to large infrastructures, and it can be deployed onto large environment where real-time optimization can take place, right? All the way from small use cases like a thermostat to other scenarios where you have to engage in pressure gauges or other relevant parameters. And lastly, this is our website and email address. If anyone wants to get in touch, we'd be delighted to talk to partners, collaborators, potential companies who want to talk with us. Thank you.
Reza, questions for yourself. Do you use off-the-shelf devices and/or could you connect to existing sensors devices, or does your approach require proprietary technology?
Yeah, I can answer this question. Actually, for this heritage buildings, because we need a minimum, damage to buildings, we designed a sensor that is power battery based and is is wireless sensor actually. But we are able to use any sensor off-the-shelf sensors or even the PLC system that they have in the buildings. We are not limited to only one type of sensor or devices. We can extract data from any type of system or sensors that it can provide in cloud connectivity.
Very good. And if I ask the next question here around on the AIoT sensors, what exactly is the AI aspect of this?
Yeah.
You mentioned AI control of temperature and humidity, but is there real gain from using AI in this? What is the AI doing in that case that standard programming smart controllers couldn't?
Yeah, actually, we use AI because we refer to my chart. We're using the temperature and humidity in the weather. It means we have a weather station that monitoring temperature and humidity in the air, and also in comparison with the building to find out the isolation of the buildings. And we're using a smart thermostat to manage the situation based on the weather forecast. And for example, in the building, in many old buildings, the thermostat is in only one single location that is not representing the real data from the whole house. The method we use is AI to monitoring the human presence in each room and to balancing the temperature and humidity based to human comfort. We managed to using the 30% saving based on this AI model that it can monitoring the human presence and temperature and humidity in each level.